The Earth is full of mystery, and its rumblings can be interpreted in many ways. Some say that the Earth speaks to us through seismic rumblings, while others say it's just rocks and minerals grinding against each other. Whatever the case may be, there are places across the planet where the ground shakes like the trembling hands of an old man. And at times, these tremblings get pretty violent. These moments are often captured by those who live and work in close proximity to active volcanoes or fault lines. But every now and then, the Earth chooses to speak loudly, even when no one is listening. And that's what happened in Spain in September 2021 when an unexpected earthquake shook the island of Tenerife, home to Mount Teide, one of the world's largest volcanoes. Could this be a sign that the sleeping giant is about to awaken after 50,000 years? Let's look at what actually went down on September 11, 2021. In Spain's Canary Islands, a volcanic tremor was recorded at Mount Teide, but no earthquakes followed, which is lucky because earthquakes can cause serious damage. This event had residents concerned because in recent history, the mountain has been quiet. The last eruption occurred during the 18th century, and although the locals knew that Mount Teide could blow again, they didn't expect it to happen anytime soon. And even if it did, they surely hoped it would be centuries from now. Now, after this surprise earthquake, people began to wonder if the volcano was getting ready to erupt tomorrow or maybe next year. Mount Teide is the highest peak in Spain, standing over the Atlantic Ocean. Its summit reaches almost 3,800 meters above sea level. It towers over the neighboring towns, making it visible from nearly anywhere on the island. From a distance it looks like a classic volcano, steep-sided and symmetrical. Up close it looks more like a giant black pebble with patches of bare rock. Despite appearing dormant, it's anything but. It's classified as an active volcano and has been rumbling with life beneath the surface. Before we look into why the Earth rumbled on this occasion, let's take a quick trip back in time to see how it came to be. The earliest signs of volcanic activity in Tenerife date back to the middle of the Atlantic period, around 4 million years ago. The oldest rocks are located near the island's coastline. They were formed from ancient eruptions that took place before the island's foundation. At that time, the landmass we know today as the island of Tenerife was nothing but a cluster of underwater seamounts. However, as more magma filled the cracks in the earth, the terrain rose. Around 1.2 million years ago, the land rose high enough out of the water to create a new island. Throughout history, Mount Teide has grown steadily taller thanks to periodic eruptions. Ash blanketed the land and flowed into the ocean. The eruptions also created new craters, some of which are still visible today. One of the most violent eruptions occurred around 70,000 years ago, when the northern flank of the volcano collapsed. This catastrophe unleashed a massive landslide and generated a tsunami so big that it hit other nearby islands. Today, evidence of this calamity can be seen in the shape of the island. You can clearly see the northern scar that stretches along the coast. Until now, the scientists have categorized Mount Teide as an effusive volcano. This means that instead of explosive eruptions, lava flows dominate. In fact, the latest official assessment indicates that it's not a matter of if, but when the volcano erupts again. The assessment was published in April 2019 in the Bulletin of the Volcanological Society of America. The authors, Pedro Gonzalez, Vicente Fernandez, and Luis Garcia, used data collected between 1992 and 2018. By analyzing seismic activity, gas emissions, and ground deformation, they concluded that Mount Teide is not dormant. Rather, it's merely resting. They go on to say that its quietude could end at any moment. But why did the scientists think the volcano might blow? Let's start with the seismic activity. There was a clear increase in the number of earthquakes recorded between 2014 and 2018. This figure increased from 5 earthquakes per year to 40. While 5 might sound low, each quake only registers between 2 and 3 on the Richter scale. These rumblings originated between 10 and 25 kilometers under the mountain. Although small, this uptick in seismic activity indicates movement within the Earth's crust. According to the experts, this pattern is typical of rising magma. They believe that molten material deep in the Earth's crust is slowly making its way upwards. If the magma continues to rise, the pressure will eventually overcome the strength of the rocks. When this happens, the volcano will violently release the built-up energy. Magma will rush toward the surface and hot lava will flow over the land. So why haven't the predictions come true yet? Why hasn't the volcano blown its lid? The answer is simple. Even though the magma is on the move, it's doing so very slowly. Scientists estimate that it's moving at a rate of about 1.5 centimeters a year. To put that in perspective, your fingernails grow faster than Mount Teide's magma. While this may be disappointing news for thrill seekers who hope to witness an imminent eruption, it's actually great news for the 100,000 people who call Tenerife home. An eruption could cause tremendous damage and lead to evacuations. Experts don't believe the current magma reservoir is big enough to cause an eruption. However, magma can continue to pool under the island. It could be that a large amount is needed to trigger an eruption. If and when it happens, experts believe that the magma will emerge in a different location. Eruptions won't occur at the summit of Mount Teide but rather in the middle of the island. Now let's get back to the events of September. The slight rumble that shook the island was caused by the sudden release of energy. Fortunately, it wasn't the beginning of an eruption. Instead, it was another magma injection. On that day, the United States Geological Survey reported a magnitude 3.5 earthquake. This happened 16 kilometers beneath the mountain. Local residents felt the rumble, but it didn't cause any destruction. And thankfully, it wasn't a foreshock. Foreshocks are early earthquakes that precede volcanic eruptions. They usually occur days, weeks, or even months before an eruption. Since no more earthquakes followed, the danger passed, but people remained tense. To monitor seismic activity, a network of 18 broadband seismometers has been installed. These instruments record both volcanic and tectonic earthquakes. So far, more than 15,000 earthquakes have been recorded. The majority are too weak to be felt, but some have reached a magnitude of 4. Although no major earthquakes have struck since September, the network continues to pick up low-intensity earthquakes. This means that even though the magma isn't moving upwards, it's still circulating. At this point, it's impossible to know if and when things will get more intense. So why does magma keep rising if it doesn't erupt? We know that magma forms deep in the Earth's crust. Heat from the core creates pockets of molten material. This magma is less dense than the surrounding solid rock, so it starts to rise. As the magma ascends, the pressure increases. Eventually, the pressure is strong enough to stop the magma's journey. The magma finds itself trapped in a reservoir several kilometers below the surface. As magma continues to build up, the pressure rises. Eventually, the pressure is released and the magma makes its way back down. This causes the minor earthquakes that shake the island. In reality, the magma behaves like air in a bottle. If you turn the bottle upside down, the air rushes to the top until it reaches the opening, then it stops. The air remains trapped inside the bottle until the pressure is released. Once again, just like the magma beneath Mount Teide. If you thought this was interesting, check out our video on Iceland's volcanic eruption, a country that lies on top of the mid-Atlantic ridge, a place where two tectonic plates are pulling apart. This allows magma to reach the surface and creates all kinds of chaos. See you there.